today when we meet for math counts. So we are finishing 11.4 and going to get into 11.5, so please make sure you have those notes out. Both of those homeworks are live on Schoology now, so you can go ahead and bust through both of those. And if we get done with class quickly today, we are going to grab Chromebooks and work on some of those. So you have your packets, right? You have 11.4 and 11.5? So how far were we in 11.4?
This is the first example.
Yeah, we were talking about this giant gold coin, right? And then, so we did some math with that. Let's go on down to this table, actually. I want to look at this table. So you're given the radius. I want you guys to go ahead and fill in terms of pi, the rest of this table. So fill in the area, the circumference, then the ratio, and then simplify the ratio, so cancel out anything that can be canceled. So if my radius is 6, to find the area, I know my area, and you could remind yourself if you want, is pi times radius squared. My circumference is pi times 2 times the radius.
Maybe actually after the example.
I'm not certain, but this is where I want to start today, because I know where I'm trying to go. Our learning targets for today are trying to see if we can determine how area and circumference are related to each other. How area and circumference just so happen to be related to each other. And if we're working in terms of pi, like you should not be multiplying by 3.14. You should be working in terms of pi. You shouldn't really need a calculator. Which is kind of a hint for what we're doing. You should not really need a calculator. Are we just sitting here doing nothing until somebody else does it for us? What were we sitting here doing? So remember that to square a number means to multiply by itself. So when I square 6 times 6 is 36, so I get 36 pi. When I square 8 times 8 gives me 64 pi. And when I square 10, I get 100 pi. Now instead of squaring the radius value, instead of our square that we had here, we actually double. That's the only difference between area and circumference. Yeah?
Did you divide to get the circumference?
Ooh, that's what we're trying to figure out. Is there a common theme with how area and circumference are related to each other? So, if I try to get my circumference here, I double my radius, double 6, 12, then I multiply by pi. I double my radius 8 and multiply by pi. And I double my radius of 10 and get 200 pi. Or 20 pi. Sorry. Any questions with what we've done so far? Most of us had this filled in as I was walking around. So now if we look at this ratio. I'm just going to write these up here while I let you guys still think. So I'm going to shut up for a minute. Don't give it away to your classmates. If you figure it out, do not give it away to your classmates. If you don't have these filled in, fill them in. How does that division of area compared to circumference have a pattern? How does it have a pattern? Andrew?
Well, this solution always it's 2, 3, 4, 5.
Mm.
And you just and the pi doesn't matter because it just cancels out with the regular division.
So if I simplify these, I really get 2, 3, 4, and 5. Dom?
You divide the area by half of the radius. That's what I did.
What did you divide?
Well, what I did was, like, I took here, I had 36, and then I divided that by 3, and then I got 12, and then 64 divided by 4. Which is
So, if I try to make an easier rule of that, because I get what you're saying, but I can kind of tell by body language, I don't know that everyone else does. Instead of talking about the division, let's talk about the multiplication. I can get the area by multiplying by half the radius. So what we can actually say here is that area is going to be the circumference times the radius divided by 2. So if I know what the radius is, which if I know what the area is, then I should know what the radius is, or I can find out the radius. Hey, Julian, can I get your attention? You know what I mean, right? Okay, just kind of disrespectful. So, this relationship, based on this table, always works. Do we think it will always work?
No. Yes.
So, sometimes your teachers are asking you trick questions, but a lot of times I'm just asking you questions to think about. So don't think it's a trick question just because I'm asking it. If it's worked 4 times, let's try it here to predict when we have a radius of 32. So I'm going to capture this real quick.
So Mr. Hansen, here you're multiplying half times.
I don't know why my computer does this sometimes. So to get the area, if we have the circumference, we can just take the circumference, multiply it by half the radius, because half the radius here was 3. My area is 3 times my circumference. Half the radius here was 4. My area is 4 times my circumference. So let's try it when we have 32. So if my radius is 32, then to find my circumference, I double it and I get 64 pi. If you do not remember your circumference formula yet, it is 2 times the radius times pi. And then to get my area, all we have to do is multiply by half the radius. So half the radius there, what's half the radius? 16. So if I do 16 times 64, I don't have that. I could do 10 times 64, get 640. Then 6 times 64 would be, you got it.
Like the full one is 1,024.
Pi.
Oh yeah.
So now, let's try this. That'd be centimeters squared, because we actually have a unit here. Centimeters. What if I just did it our old way, where area equals pi r squared? So if I do area equals pi times radius squared, but what's 32 squared? No, 32 squared.
Oh, that's 1,024.
It is 1,024. We then multiply by pi. This rule will always work. So somewhere in your notes, make sure you have the rule. Area equals your circumference times radius over 2. Or half radius, but that's what radius over 2 is. Any questions on this? It's a very cool relationship. Whether or not you think it's as awesome as I do. It could someday win you $1 million. Who knows? Flip to the back. We're going to kind of move quickly through this, see if we can get through 11.5 today as well. So now it tells me the ratio of area to circumference. So we saw up here in the table that ratio of area to circumference, don't worry about their problem yet. So ignore what their problem says. We learned that ratio, that right-hand column, always equaled what? Because it changes depending on the size of the circle, but it's always going to equal, Sean? Half the radius. So we could either say half the radius, or we could say radius divided by 2. These are the same thing. Half of the radius, so 1/2 times the radius, or radius divided by 2 are the same thing. So they then tell us that ratio is 11. So we can then just say, okay, this is 11. What's that really tell me? If I know that is 11, I could do the math, or I could actually just mentally make this inference and do the math in my head. Monica?
Radius is equal to 5.
Ooh, close. If this is half the radius,
Oh, 22.
yeah, we would have to double, and that will give us that the radius is actually 22. Now, we don't have units right now, so we're just going to have a unitless value for the moment. Or if you wanted, that would just be units, since we don't know it. But they want the circumference. So, more just remembering our formula, circumference, do I square my radius or double my radius? Anish? Double it, so this becomes a circumference of 44, not, no. It's not just double your radius, it's double your radius times the pi. And because circumference is length, it's still just units. And they said leave our answer in terms of pi. If it did not say that, we could multiply it out. And instead of pi, we use 3.14. I will be getting my pi poster hung up here as soon as our Office Max order comes in. We'll also have more highlighters too when that order comes in. Questions? So now, is there a way to show that area divided by circumference equals half r? So as we get further up into your mathematical career, one of the things that you guys are going to do is, or be asked to do, is you're going to be asked to prove things. So we can say, like, okay, we believe that this is true. Okay, we've shown that this is true, but we need to make a proof of it. So there are proofs of why the circumference formula works, and there are proofs of why the area formula works. We need to make a proof for why this formula works. So go ahead and on your paper, we're going to start with like a little question mark. We want to prove, and you could even put like proof, that area divided by circumference will in the end, way over here, equal our half radius. But man, all we have right now is a table of like 6 or so examples at this point that work. What's one thing that we've done in solving like equations or inequalities or all these different things when I have a variable but it's not really helping me that much? Like I've got a variable, maybe I'm asking this question poorly, I know I am. So I've got a value, you can just throw that away, thank you. It's just to get you here, really. So I've got area and I've got circumference, but I don't want either of these in my answer. The only variable I actually want in my answer is the radius. Is there a way that I can replace my A value or my C value with something else, called substitution, that will let me switch what variables I'm using? Do I know what A equals using some other variable? Or using some other value? I guess maybe variable is the wrong word. I think you're mentally on the right track at least, judging by your body language compared to other people. What are you thinking, Andrew?
It's either pi or c times half all.
Now, pi is not a variable. Let's remember that. Pi is a Greek letter, but it stands for a number, right? So pi is actually, as scary as this is to talk about, pi is a constant. We know its value. Although its value is endless, we don't know all the way out to the end. It's a number that we know.
So, C times half a bar. No, not half a bar.
Take a minute to talk with your neighbor. See if you can figure out what we should use to substitute in here. We want to end up, in the end, only having radius and some numbers. Take a minute. Oh, from cutting cards this morning. Thank you. Yeah. Oh, I should announce this and make sure it's on the video for anyone who wasn't here this morning or didn't hear us. The reason that my goatee is blue and my mustache, if you can even call them that, my attempts at a goatee and or mustache are colored today is because our math counts team won the golden calculator. So we had our local Worthington competition today, and we won the golden calculator.
Oh, you should have your hair purple, and then that would have went with
I also work at Lifetime and cannot have colored hair to go into work there. So I like that job. I get a free gym membership there. So I'd like to keep that job. Yeah, like over there. Come climb with me sometime. Can you go there?
Yeah, I do so.
I'm there Mondays and Wednesdays, most Mondays and Wednesdays. What's up? We did, well, mine's not as good as yours.
Why can't you have colored hair?
It's just a professional thing. Like, we try to look professional. I mean, I could, probably, if I thought about it, like, talk to them, but I just need to stay professional. Colored hair in the adult world is kind of frowned upon. Does anybody think they have an idea of what we could substitute in here with? Honestly?
Choose a number for the area and find the circumference.
We could, but that's only going to give us one more example that could work. We need not just an example that works, we need, like, the end-all, be-all, definitive, this will always work. Ozzy?
You can put in your formulas.
If I put in my other formulas that I know. What's our formula that we know for area? Ooh, no.
R squared.
The original formula for area that we had is pi r squared. The only letter or variable I'm using here is radius. Do I have a formula for circumference that uses radius? Yeah, 2 times the radius times pi. Now, we got to simplify this out a little bit. What does it mean when I have radius squared? How many r's are actually in the numerator? 2, but it's not 2r, because that would be 2 times r. This is pi times r. Because remember, radius squared is radius times itself. Radius times itself. Now I'm going to change order. This is commutative property. It doesn't change anything, actually. I'm going to move my pi out front. Then I'm going to move my radius next. And then I'm going to put my 2. So, does anyone have questions on what I did to the denominator? All I did was change order. Didn't actually change what's there.
Oh, I see.
Jeremiah, what do you see?
All you did was, like, you just broke it down. That's all you really did.
Okay. So now, anybody I haven't talked with yet today, see anything I can do to make this easier? Moon, what's 5 divided by 5? 7 divided by 7? Pi divided by pi? This cancels out to be 1. Hey, Jeremiah, what's r divided by r?
1. Wait, which Jeremiah?
Exactly, doesn't matter. That cancels out to be 1. And all we end up with is r. divided by 2. Definitive proof that this will always work. Because no matter what numbers we plug in, we didn't choose any numbers. We used pi, which is a constant, not changing, we know what it is, and we used our radius, which would be the same. If that's the same circle, your radius would be your radius. This will always work. There's our proof that lets us make this a rule instead of just a theory. Any questions on why this worked? Anyone think that's pretty sweet? Yeah, like you're going to be able to do a lot of this as you get deeper into math. Use the formulas that you know to make better, easier formulas. All right, get 11.5, flip to that one. This gets really fun. And some of you guys, I think, are going to have a lot of fun with your homework tonight. Because, like, the problem-solving type aspects of, like, it's interesting. It's the type of problem-solving that we're doing is not, I don't know how to phrase this. It's not extremely challenging, but it's interesting. So, imagine we have a t-shirt company. And actually, so this is a good chance to plug this a little bit. So, Dom, I need to email your mom, actually. We are planning to make Phoenix t-shirts for the 10-year anniversary. So let's imagine that we make a round logo. Let's imagine that we make a round logo. Now, we're not saying that we're going to use like the Phoenix logo, but let's imagine we make a round one. And we're going to print it in, like, normally when you print shirts, you screen print. There's a square space or rectangular space that you can fill up. You don't have to fill the whole thing. So we fill the round space in the middle. But then somebody says, now what if we don't make it giant? What if we make it smaller, but we, like, clone it? And we clone it multiple times. And then what if we, like, make it smaller, clone it multiple times again? So we compare these 4 logos. And we're arguing cost, right? Cost goes down if you use less ink. So we want to know which of these uses less ink. So I'm going to challenge you guys. This part of the room, figure out plan A, how much green ink it uses. So you're solving the area of the circle. You guys use plan B. Actually, let's have you guys be plan A this week because there's less of you. You guys be plan B, and you guys be plan C. So you want to figure out how much ink is only in the circles. So plan A, plan B, plan C. Take a minute. So plan B, plan C, people. If this is 24, how do you figure out this distance? And then that distance is that distance. So this is your diameter.
Yes.
Is this a pie thing? That makes pay the bill off. Area.
20 seconds.
I don't know.
That's been longer than a minute, but considering I said take a minute, I've already lied. Oh, I try not to. I do my darndest. And plan A, people. Evie.
Yeah.
What's your radius for plan A?
12.
12. So then when you found your area, what was the area of that circle?
144 pi inches squared.
144 pi inches squared. Oh, you can leave your answer in terms of pi, by the way. Colin, what'd you guys find as your radius for those smaller circles?
So we found 60.
Yeah, 6 was your radius. So each circle had an area of what?
It had an area of
So what's 6 times itself? 6 times 6?
36.
36. So we get 36 pi. But that's each circle. What do all 4 circles here have together?
We would have 144.
No, we haven't talked yet today. What'd you find as the radius of our smallest circles up here? 3, which means each one has an area of, what's 3 times 3? 9 pi. And all together, all 9 of them have an area of,
144.
is it?
Yeah.
Radius is 4.
Yeah, radius is
Okay. I was about to say, something's not making sense here. Radius is 4, area is 16 pi. My apologies for going the wrong road. Here's my question, though. And actually, I have some coloring books that I'm about to bring in for my Marth class. Even if you guys did not sign up for my Friday Creative option, you can like pull things from the coloring books if you want. I can copy whatever you guys want. Would the area of ink used be the same if we cut this and made 16 circles, or 25 circles,
Yes.
or 100 circles,
Yes.
or 1,000 circles?
Yeah, it would change.
That's really
it's like
cool.
The triangle circle. Like, you just make it a circle and slow, but it's still. It'll never go over.
So, anyone here ever heard of fractals? Any of your 6th grade or elementary teachers talk to you about this stuff? So, if you've never heard of fractals, if you're interested in the art side of math, look it up. FRAC, like fraction, but then TALS.
Oh wait.
It's a really interesting branch of mathematics. You got something, Elena?
I was just gonna say, well, I was gonna like ask what they are. Aren't they just like the patterns?
Yeah, it's so like where something keeps kind of either dividing to make smaller ones or multiplying to make bigger ones. So right here, we stayed in the same amount of space, but we kept cutting it into more pieces, but we still stayed with the same area. So when we talk about fractals, so it's something like, this is a really simple one, but you could continuously zoom because it just gets smaller and smaller and smaller, or bigger, 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 kind of, depending on how you think about it. So it's hard to find images that have good.
Look up fractals.
So these are the edges. Crap. The edges have the fractal. So it's hard to see because the resolution's really low. But yeah, look it up if you want to learn more about it.
But why is it that the circles here?
Because of the relationship they have. Because we have the area doing 9 times or 4 times. Look at what we did. We took the circle, the one big circle, cut it into fourths, but then we had to multiply by 4 because we had 4 of them. So we took your radius and divided by 4, but then we multiplied by 4 because we had 4 of them. Or here in Plan C, we took your radius and we divided it in like to the third of what it was, but really it's the not because the diameter is the third. So here diameter is 24, radius is 12. Here diameter is 12. Ooh, that's not good. And radius is 6. So there our radius is half the original. But when I square, remember that 2 squared or half squared becomes either 4 or a fourth. Then I multiply by 4, because I have 4 of them, and I get back where I need to be. Here, our radius...
Wait, you square
Square the 6. Just keep having it.
Because remember that area is pi times your radius squared. So if the radius value is now, hey guys, can we stop with the noises? I don't know who's doing it, but stop. If I need to figure out who's doing it and send you to the office, I guess that's going to become my job. So then this radius is 4, so it's a third of the original one. But then when I square it, I really get a ninth of the original area. But then I have 9 of them. So I do 9 times that ninth area, and I still get back to the original what I wanted. This is just a really cool relationship we're trying to get you to see. It's not like part of the standards. It's just really cool. So the part of the standards is understanding how they relate to each other. So we now want to do some work with complex figures. Anyone know the definition for a complex figure or a complex shape? It is actually one of our vocab words for this year. So as we start using them, it will be easy to think about. This is a complex figure. Can anyone just deduce why it's complex and not simple? What do you think, Jim?
More than one part.
It's got more than one part, and that involves more than one type of shape. So we've got a rectangle, and then what? Two half circles. So wait, really we have a circle. So quite frankly, what we have here is a rectangle and a circle, but it's broken. So this is our school's new track, hypothetically speaking, of course. And we know that the radius of this track, to make the track the correct length, the radius of the corner section has to be 36.4 meters. We need to figure out how much grass there is going to be inside the entire thing. So we need to figure out not only this space, but also the space inside the corner areas. I want to challenge you guys to try to do this on your own, especially because I feel like I need to reorient my board. Take a minute and 50 seconds. Go. Yeah, I don't know. I think I'm going to need to get somebody in here to look at this. If you think you're getting there, compare with somebody. You have 40 seconds left. I actually feel like the circular part here is the easiest to start with. The rectangle tends to give people the most issues. 12 seconds. Ooh, yeah, we don't know that it's a square. You have to figure out, well, actually, it's not a square. I'll go ahead and tell you. But we don't know what it is till we figure out the other side of it. And that's time. Ozzy, for the circle, so we did pi times radius squared. What's your radius here?
The radius is 36.4 meters.
That's told to us right over here. So when I do that area, we get 24.96, you said?
Yeah, and then just keep that because there's two halves on the field. So
Yeah. So we could have either, for this part, found it and divided it by 2 and then multiplied by 2. kind of like what we did with the circles up there. We cut them into pieces and then we multiplied them. Or save yourself time and effort and just keep the full circle area. Now, when we go to do the area of the red space there,
You didn't have it add a pi times.
no, because we used pi here. Well, did you already multiply by pi? Or not yet? No? So you got to tell me pi then in your answer. So all you said was 1,324 or whatever. This has to then be pi meters squared if you leave it in terms of pi. But it says use 3.14 for pi. So if I use 3.14 for pi, this comes out to be, Sean?
4,160.37
Point what?
37.
Now my rectangle area. And the reason we can't leave this in pi, the red area will not involve pi. So since the red area won't involve pi, we can't leave our values in terms of pi. My red area though, okay, I know the 85. But what does that multiply with? Elena?
72.8.
How'd you figure that out?
Because, like, for the radius for the semicircle, I did that and I just multiplied it by 2. No. Yes. Yeah.
That 36.4 is the same as this distance. And that is half the height of your rectangle. So that 85 multiplies by 72.8. And that area comes out to be, do you have it, Elena?
6,188.
6,188.
Yes.
Any decimal?
No.
Then the whole track, or the whole space in the track, when we add these up, our total area becomes
11,672.374 meters squared. That is a big field. 744.
yeah, I missed it. My brain went on to the 4 before it got to the 7.
Why is that so big?
Well, realize that's meters squared. So a square meter is this wide by this wide. So that space right here, 11,000 of those.
That's not
So like a football field is, how many meters wide? Isn't it 50? Or yards wide? Is it half as wide as it is long? A football field?
yeah, I think so.
So if we use approximate measurements, and we say it's about 100 meters long, 50 meters wide, that would be 5,000 square meters, approximately.
Wait,
If we use really rough measurements, yeah.
so isn't a track supposed to be like about the circumference of a football field?
A football field can fit inside of it. But realize this could be a half-mile track, which would be bigger. Most high school tracks are quarter-mile tracks or fifth-mile tracks. At our fairgrounds, like our county fairgrounds, not here, I'm talking in Coshocton, but probably here too, we have a half-mile track. So the inside of it's really big because the track itself is a half-mile in length. We have like 3 or 4 minutes left, so I want you to take the remaining time to try to solve as many of these as you can, either on your own or with a partner, and we will go through and check these tomorrow
Wait.
and wrap this chapter up. Wait.
Okay, yeah. On the board, I'm not sure if it's like final answer.
I don't think it's
because I got something different.
Yeah.
I got 10,348.
Who gave me this, guys?
Me.
What'd you do? Will you check your work and see?
Oh yeah, I got 10,000.
I got 10,000.
So are we good on the 6,188?
Yeah.
And we're good on the 4,160?
Yeah.
But it's
I
10,000.
think she just added wrong.
Yeah, check what you punched into your calculator. I think you hit a number wrong.
Because it's
10,348.37.
10,348.37.
Yeah.
There we go.
Meters squared. Yeah, that didn't look great because we had 61 and 42. That can't get you to 11. Good catch, guys. So take the last 3 minutes, Trying to solve these window type problems.
Is those 24 inches? That radius or the back?
That's the diameter. 24 is all the way across.
My mom's saying like
People that still need to take the chapter 10 test, I can't give anybody else their test back until you take it. But you were gone like for COSI, so I know that. But please come take it as soon as you can. I have everybody else's graded and done. If you're dying to know what you got, assume that you got a mastery. Pretty much everybody that has taken the test mastered it. Which is good, because angles, like it's geometry, we should... It's good stuff. We move through it quick. On the example problem, because I know a couple people might keep working on this this evening, maybe, who knows. Notice that it says, what percent of the area of the blue zone, can I get your attention for like 2 seconds? Imagine this is stacked, and the blue zone is anything in here, and the red zone is just the ring. So, this is where this example gets really hard. What percent of the area of the blue zone is the area of the red zone? You have to calculate a donut area. So, if you try to do this on your own, we'll talk about these sort of problems tomorrow. To calculate the red area, you have to find the whole circle and then take away the little circle. Be very, very careful if you try that.